Yeah.
We should close it. As our friend in the morning says.
All right, we're going to go ahead and get started. Welcome to the what? Yeah, we're getting started. Welcome to the October 2022 meeting of the Silver Creek Amateur Radio State Association. I am, of course, Jason McCormick, NADI, the president, of course, and we will start with introductions.
Good evening. My name is Bob. I'm a new member of the club on 88 DSS.
And newly licensed, yeah.
Hi, my name's Matt. I'm Bob's son, also newly licensed.
Ollie, yeah.
KD DSS.
Awesome.
Randy, go ahead, Randy.
KE8 TLB, Brandon Breakthrough.
Randy, where?
The brake truck.
Oh, the brake truck. Good.
My name is Russ, KD BYT. I'm your secretary.
Randy's wife.
Roger, KD8 URT.
Roger. Good.
Tim, KF8XW. That's number.
All right.
Ed, K8OIM. Keith, K8TQR. Russ from the Diamond, KD8 URT.
Thank you.
That's Mark.
My name is Mark, and I'm FA, SARA Paco Show.
Chuck KE8 DFH.
DFH. Hey, Ron.
Hey, Ronnie.
Kilo Delta 80 Lima Golf. Just Nick.
Hey, Nick. I'm Jim, NACAI, Philadelphia. I'm Wolf, I'm Ron, co-worker studying.
Awesome. All right. Awesome. December. First week in December, we have a session.
Thank you very much. Appreciate it.
Kilo Delta 80 for that uniform.
Ted, NAF 2P.
Dave, KC8 BBB.
Zeke, AB8OU. Jeff, W8TB, I'm your treasurer.
Stefan, November 8 Whiskey Bravo, Vice President.
Bill from Sillyville, KNA WTK. Sillyville.
And Ken, Digital Dorsey, Kilo Alpha 8, Oscar Alpha Delta.
All right. We'll have 2 minutes. We'll have 2 minutes, 2 sets of minutes next month to approve. There are no announcements, so we'll go right.
You didn't get the minute?
I got them this afternoon. I didn't have time to do anything with them, and it was
You're
too.
fine.
Wow.
Thanks, Russ.
All right, thanks, guys.
There will be reviews in November meetings. Treasurer's report.
Can I do that?
Can I just say, oh, it's fine?
Yeah, you could.
Yeah, it's fine.
We have enough time and credit, don't worry.
This might not make the meeting too.
All right, we did have some expenses, picnic food and beverage, picnic prizes. We did have some income club dues, you can see that there. We also had some expense for repeater infrastructure upgrades. I'm sure we'll talk about that. And also, and this is just gross sales, but fantastic number. You guys bought a lot of stuff. Fall apparel sales, doing great. Ending 77.45.85.
All right. Any questions on the treasurer's report? A motion to approve?
Approve.
Stefan, second. Anybody? Eric? All those in favor?
Aye.
Any opposed? All right. Executive committee report. We did meet on the gee, I'm blanking now, 2 Sundays ago. 3 Sundays ago.
When I came back from October 1st,
Yeah,
2nd, October 2nd.
So we talked about some upcoming events, Fox Hunt, which we'll talk about in a few minutes, Christmas party, which we'll talk about in a few minutes, technical investments in the repeater, which we'll also talk about in a few minutes, and org structure and leadership. So at the moment, what we've decided is we're going to kind of leave the Education and Operation Committee kind of dormant for the moment. The prevailing thought, as I think I've mentioned before, is rather than try to make them formal like we did, try to work more in kind of communities of people who are interested in different topics. Still working that out. On the leadership update, just a reminder, we do nominate officers in January, or excuse me, in February. We start discussion in January, we nominate in February, voting is in March. We will be electing new officers. I will not be running again as president. I don't know if everyone else who's an officer now will be running again, but just a reminder, those offices are open. If you have an interest in helping out leading the club, it's not a popularity contest. We are looking for people who are interested in getting involved. You don't have to be the world's greatest radio operator. You don't even have to be a longtime ham. If you have interest in leadership, if you think you can help organize and lead stuff, we're more than happy for you to get involved. So just something to keep in the back of your mind for next year. Something to start thinking about. As I said, most of the topics we're going to cover in a few minutes, but is there anything else on the executive committee topic? All right, a couple upcoming items. The SARA Christmas party, as you recall, we have this on the second Thursday of the month. So this year it'll be on Thursday, December 8th. We'll be at Bo's Grill, which is attached to the Hilton in West Akron on Market Street. We get a nice little room. Gary does a nice little program, has some door prizes, things like that. It's a great time. So put that on your calendar, and we'll have more details about that by next month's meeting for sure.
And no meeting in December.
And then, yes, and then there is no meeting, there's no regular meeting in December on what would be, I guess, the 15th.
You have a time on that party?
I do. I don't know. Gary hasn't booked the room or set up anything yet. Probably 6 o'clock, I think, is what time.
Between 6 and 7, yeah, 6 usually. Open bar.
All right, Winter Field Day. Last year we did rent the Legion Hall for Winter Field Day. We've decided we're not going to do that this year. So Winter Field Day is going to be January 29th and 30th, 2023. The primary reason that we're not renting the hall is the Winter Field Day organization seems to be in flux, turmoil. I'm not sure. I don't know if there's politics behind it or they're just trying to relaunch it. If you go to their website, there's no rules for 2023. They just said we're redoing all the rules. We'll let you know, and nothing has been posted. So we're not going to plan on any sort of major event for a event that may not happen as we would expect it to.
Right.
Renting the Legion Hall is not a inexpensive endeavor, and all the time we would put into it to then get on the air and not have a Winter Field Day population would be kind of problematic. What we are planning on doing, and we don't have all of the details of this worked out yet, very much in flux. If there is some sort of Winter Field Day that happens, what we're going to do, and we've seen this, some of us have seen this done in other venues. What we think we're going to do is a virtual event where everybody can operate from home on their own radio, and then we'll have a virtual meeting room or two where people can dial in from their shack or wherever, talk about, hear what other people are doing, swap stories, whatever, probably do it, that kind of thing. And then we're also going to work on having some sort of volunteer hosts, probably like on a 1-to-1 or maybe 1-to-2 basis. people who are willing to have someone over to their shack and do some winter field day operating. We're gonna try to get some people who are willing to host, some people who are interested in operating, and then probably try to match them up by geography or something like that. So that's kind of what we're thinking for winter field day. Obviously, that is all going to depend on if winter field day actually is a thing. They had promised they were going to have all the new information up by October, and there's nothing there. So it's a great event. I hope they pull it together, but it's not clear. So just wanted to keep people updated on where the club was at with that particular topic. Any questions on winter field day? Yeah, Fred.
Well, we could really make it real, like get a tank, do it outside.
We could.
In the Army, we do stuff like that.
Yeah, I mean, the issue then also is that we have to rent like an outfitter's tent, a heater, and find a place and get permits and all that kind of stuff. So, yeah, Mark.
You're not gonna expect to hear me, oh, I got a handheld.
Yeah.
That's a Sunday for Monday.
I think that was Saturday to Sunday. I might have the dates wrong. Might be 20. You know what? I got that off the website, so their website might have the wrong dates on it. So, 20 and 29th, okay. Huh? Yeah, it's a Saturday. It's just like regular field days, Saturday or something. So, all right. So this is sort of the main topic of tonight's meeting. So this has been circulating through the technical committee and then the executive committee. We've been talking about technical investment in the club. We have been blessed with a pretty significant amount of members that's bringing in a good amount of revenue, and we don't want to sit on that money. We're not an investment bank. We're not trying to collect interest on it. We want to spend it for the use of the club. One of the things that we want to do, and we're going to proceed unless there's strong objection, is we want to replace the actual repeater radio components of the 2-meter machine. The system right now is about 7 years old. The main radio is a Bridgecom VCR50V. It's a reasonably decent amateur radio quality repeater. It was bought about 7 years ago when the club was having some on-air issues with their equipment. It is not a commercial grade repeater, and it's not, especially notably, it's not a full duty power type repeater. And there's a couple of reasons we want to replace it. The first one is we have had some problems with the unit itself. There's been a couple cases where, for reasons that we have not been able to figure out, the transmitter just won't key, period. We go at it, we stare at it, we tap it, like we key up the radio, the PTT light just does nothing, and the radio won't transmit. After you power cycle it a couple times, it seems to work again. It's happened twice this year. We're going to start drafting volunteers to drive out the toilets down and push the button if we have to. We also have some audio quality issues. If you have a really good speaker, there's a really high-pitched audio line in the receive audio path that we've never been able to get rid of. There's also a fan noise that we can't get rid of due to how the design of the repeater is. So there's just some quality issues there. And then the thing that's really pushing us to do this is we've talked pretty extensively to radio vendors in the commercial, upper end space. And what we're finding is the commercial vendors basically are ending all of their analog FM repeaters. Motorola, Kenwood, all the companies that make the real solid commercial grade repeaters are doing away with what we've called ham-friendly type systems. The Kenwood NXR is probably the last one that's still in production that would be considered ham-friendly in that it has a breakout port for an external controller and some of the ham features that hams want that commercial radio users really don't want to have. And they're all going end of life. As a matter of fact, the Kenwood NXR 710 is the last currently in production radio that we know of. I mean, we've talked to Motorola, Kenwood, ICOM. I even tried Codan, Tate, which might work, but we needed a small dump truck of gold also to buy one of those. What we're finding is, and I talked to Vassar Communications, they're actually a vendor we use at work. They're pretty reputable. They warned us that this was going to be the last Kenwood model that's going to be ham friendly. All of the upcoming Kenwood models are all going to be either P25 or NXDN, and they're all going to be digital first, trunking first, all of the features that are really great for commercial systems that hams don't want. So what we want to do is kind of get in sort of at the tail end of commercial grade equipment that we can probably get a good 20 years out of as a club for the 2-meter repeater. So what we're planning on doing is replacing the Bridgecom VCR50 with a Kenwood NXR 710K. The cost is going to be about $2,500, $2,550, give or take, some tax and things like that. This will be paid out of the general fund and not the repeater fund. So as you remember, the repeater fund is for an emergency replacement of the system if we need to get back on the air. We can take it out of the repeater fund, but then at the end of the year, we just put the money back in the repeater fund from the general fund. So it's kind of no point in doing that. What we're looking at buying is, as I mentioned, a Kenwood TKR, or excuse me, an NXR 710K. It's about $2,400, a little more than that. It is a brand new unit, new manufacturer. The Vassar that we're going to buy it from will do all of the pre-qualification checkout. The NXRs, the TKRs, they have a front-end pre-selector. They'll do all of the tuning for our frequencies on the pre-selector, and they'll do a burn-in test and everything to make sure that it's a good unit. We're going to purchase a professionally made interface cable to go from the NXR to the SCOM controller. That's going to take out a bunch of custom pieces that we have. Right now we have a custom PL decoder, we have a custom squelch board, we have a custom cable harness with capacitors built into it to get around noise issues with the Bridgecom. This would be a professionally made, well-shielded, appropriate length, right connection on both ends cable to connect the radio to the controller. This would probably be about a 4 to 6 hour outage of 3.9, depending on how much fiddling we have to do with the SCOM program. It could be as short as 2, but I'm over-promise and under-promise and over-deliver, or over-promise, over-deliver. I don't know. Anyway, this will probably be on a Saturday morning. We have talked about what we're going to do overall as a club strategy for hardware. For the very short term, we would keep the VCR 50 as a reserve unit. I'll just put it on the shelf in my basement. If we were in an emergency, break it back out, hook it up without some of the customizations that we put on it, just to get us back on the air while we either get the Kenwood repaired or something, if it was obliterated by lightning, figure out what our other step was. Over the long term, what we'll probably do is attempt to acquire another NXR 710, probably used. Probably when some of the new models come out, you start to see some of the older models come out on programmatic replacement. I'll talk to Vasu and say, hey, if you are pulling these out and they seem like they're in good shape, let us know. We'll buy one from you. Or we might look at a TKR 710 V2. That's a much older model. Those are probably about 20 years old if we found one of those. Again, they're a rock solid radio, but the goal of this is to sort of invest in a brand new system that's going to be around for the next 20 years, right? And that's the kind of lifetime you can get out of commercial type equipment. So that was a lot of detail about the 2-meter repeater. What questions can I answer for people?
Back up one slide. 2,550. And go forward one slide. Okay, got it.
Yeah, it's
okay. Yeah.
There's a couple different vendors on like eBay that make cables, and then there's some other. I haven't priced out. I haven't said that the cable's going to be $119.47 or.
Okay. I just wanted to get the numbers straight.
Yeah.
Thank you.
Any comments, questions, concerns, thoughts?
Do we need to vote on this or?
We don't technically need to vote on it. I'm happy to hold a vote if people would like that. We're mostly looking to make sure that no one's like, hey, this is an incredible waste of club money. We don't want you to do this. I mean, the executive committee, we can do it. We don't want to just randomly do it, really. So, was there a question over here? So, yeah.
What's the status of the antennas and duplex?
They're fine. They're the antennas. They're all less than 10 years old. The 2-meter one is a CommScope 224. I think it's a 4-bay, or no, it's a 1-bay 2-meter. The UHF one is a CommScope something or other. I think it's a 16-4 or 16-bay UHF. The duplexers are in really good shape. They're TXRX Systems duplexers, but big, full halfway of cans. The only other thing we mentioned, I'll mention this in the slide, we did just buy a whole bunch of new cabling to replace some of the older cable. So.
You know, we've got the money.
Yeah.
Let's do it.
Make it so, yeah.
And really, I mean, it really is about this long-term issue. I mean, the marketplace for FM analog repeaters is going away.
What kind of time frame?
They have it in stock. As soon as I buy it, I'll drive out to Avon and pick it up. It's Avon shipping, take a little trip. Buy two, they only have one. So we can buy two. Like, we could ask for another, but then we really are talking about $5,000.
Right.
We have the money. Do we want to spend that all at once? You know, I don't want to like drain the whole treasury either. We're trying
But we
to,
also want one as a backup.
right, and we can do it
And-
next year.
But there are going to be available new.
They will not be available new in box, no. So, what I could do is I could ask Vasu if they come across another one to let us know, and we can talk about it. I mean, well, I take that back. I'm sorry, I do take that back. I don't have the details up here. The radio itself is $1,900 plus tax. The rest of this is the programming software, the cables, and some of those. So the radio, I'm sorry, the radio unit itself is like $1,950 plus
So
tax.
$2 grand.
Yeah, $2 grand. So.
And if push comes to shove, we have money in the repeater fund itself.
We do. Now, specifically though, we don't want to spend that unless it's an emergency, right? I mean, that is the whole
What kind of emergency?
high tornado wiped out the repeater site or something.
Yeah, at this point, we can only get one anyway, so I mean, what's the?
Well,
fighting?
Vasu only has one. They can put out a call to the Kenwood network and say, hey, does anyone else have another one? Can we get one? Maybe. I
Just
don't
one
know.
as a standby, because then you don't have to worry about the cable. You know, everything's the same. So
Yeah.
just plug and play.
Yeah, but then it's,
Programming software, all that would be identical.
Yeah,
So you only
Yeah.
need one set of that.
right. I think I'll look into getting the second one.
I could ask Vasu about it, and we could maybe look at buying it, next month or something like that.
Plug the club along.
Again, we have the money, right? I mean, if you go back to the treasurer's report, we've got $7,700. We could very easily spend $5,000 if we wanted to.
Yeah,
I mean-
but I got a question.
Yeah.
Spend $5,000, but you want some money in the reserve.
Well, for what reason though?
Right, I mean, well, so,
You
you're
don't
right.
want to use the whole money.
Well, but to Bill's points, I mean, so hypothetical argument, let's say we spent $5,000 on this, we still have $2,700 and we start collecting dues in January
Like,
for 2024.
Yeah.
So for 2023, 2024.
And if there is a major problem and we need to replace it,
Then we have to.
we got it.
Yeah. Yeah, I heard.
Do a matching thing.
I'm sorry.
Do some kind of matching thing, we put up so much money and if members match it, why?
Oh, donations, I guess?
Yeah, but I mean, we could do that. I mean, that's one possibility.
well, I think at this point, let's just focus on what we have and move forward, because
What-
I think
Yeah.
we need it now, we don't have the,
Well, yeah, what I would say is, why don't we do this?
Buy the one.
I'll buy the one now that we already, I mean, I have a quote and everything, like they're ready to go as soon as we agree. I'll pull the trigger on getting that one for sure.
Right.
And then I'll ask him to say, can you get another one? What's it gonna cost? What's the time frame? And then we can maybe talk about.
What's involved with the software?
It's just programming.
We own it?
Yeah, once we have it, we own it, we can use it as many, yeah, we can use, it's not like a per radio license. We buy the software, it works. So.
Cool.
So is that, I mean, does that sound good? I mean, what I'll do is we'll buy this one, get it going, and then I'll talk to Vince and Vasu and say, hey, we'd like to buy a second one.
Make us a deal.
Yeah, make us a deal.
Yeah.
Well, I think he did make us a deal on this one. I think the problem is they're becoming scarce. I mean, there is interest in the amateur community for clubs that have money. They're looking to.
Maybe that's the whole reason we get one now where we can.
Yeah.
Get two now.
We can invest it. Feel like our little nest egg.
We could sell it to another club.
Well, and that's a good point. I mean, we could, if we did buy two, then we could sell the bridge gun. We could probably sell it for about $500, $600. I think they retail new for about $1,200, $1,300. And we would have to be upfront about the issues we've had on with it, I think, and its use. I mean, our repeater gets a fair amount of use for amateur repeaters.
Yes, it does.
So we could probably sell it for, $500, something like that. So, is anyone opposed that plan? All right. Well, then that'll modify this slide slightly. So we did buy, if you've ever seen ABR Industries, they're at all the big ham fests. They're a custom cable manufacturer. They're big in like the microwave commercial space, I guess. So we did purchase for every interlinking cable, and there's a surprising number of them in a repeater system. For every cable that we did not already have either, so a duplexer cable, we don't want to replace the duplexer cables because those were like micro-millimeter matched to the right frequency. But everything else that we knew wasn't built or purchased in the last 3 years, that's a known double shielded Teflon coax cable. We bought a replacement for it. I went out to the site, I measured every connector, the distance for every connector, so that we can purchase exact length cabling, so we don't have any loops in any of the cables. And we also bought them with the correct angle for strain release. So for example, on the top of the amp, there's an end connector that sticks straight out the back. And instead of putting a straight connector that'll bend, we're actually bought like a 90-degree connector built right into the cable so that it'll hang down. So we bought all of those cables. Basically, it'll end up recabling everything in the 2-meter audio path, transmit and receive, and then it replaces, if I get this wrong, I'm sorry, but I believe it replaces the transmit path out of the 70-centimeter machine. And then that'll have all within most of the cabling at that point will be brand new, double shielded, high quality cable. And then a few pieces are still going to be a couple-year-old double shielded coax custom mades that we've had done. So since we're going to buy the repeater, we'll install all that at the same time, all the new cabling, all that at the same time. The other issue, we had talked last month about adding analog as a multi-mode option to the 70-center machine. I am happy to report we did that and then immediately turned it off. We found out that sometime in the last several years, when 442.275 was analog to when we made it digital to now, there is some sort of local interference on the input channel of the repeater. It does not seem to affect the digital modes, completely wipes out audio. Specifically, it's like a pulsating noise. If you go to Doylestown, you can hear it. It's like a kind of noise. The audio, it just kind of interferes with the audio a little bit, completely wipes out the PL tone in the audio stream. So you can't keep the audio open for more than about 1.5 seconds So all you hear is the whole time you're talking. It's not, we thought maybe it was something local in the repeater hut. It's not. It's definitely somewhere outside, but close enough that you can't hear the noise very far away from Doylestown. But basically, unless you're standing right under the repeater with 50 watts, like I did in my truck, I could blast through the noise and it was fine. But everything else we tried is out. So doing anything more with 275 is probably going to be on hold for a while, unless someone is really, really interested in doing some noise finding. I know I don't have time to do it right now, and I know John doesn't. I haven't talked to Marty. I don't know if he has time. If someone's really interested in that, we can talk to you about borrowing equipment and how to do it. But the main people who normally do that aren't probably going to get to that this fall. So just kind of a status update on that. So that was a rich technical committee update. Any questions, thoughts, concerns? Do you have any feelings? Any logic you'd like to share? Yeah. No, Bill, we don't want all your feelings, just the feelings on the technical committee.
Well, we love you, but please.
All right. Fox Hunt. If you haven't signed up for the Fox Hunt, sign up for the Fox Hunt. Bob, newer members probably don't know Bob. He hasn't been around too much. He's had some health issues. But he is really looking forward to putting on a Fox Hunt. It's going to be Saturday, October 29th, starts at 10 a.m. If you're going to chase the fox, we're going to start at the parking lot at Bueller's in Wadsworth on 94. You need to be there before 10:30. We're going to start right at 10:30. If you're not familiar with fox hunting, it's essentially radio direction finding. So Bob and Dave Spondike, NT8D, are going to be the fox. They will hide the transmitter somewhere in the area, and essentially you try to direction find it. You can do this with something as simple as an HT with a reasonably good S meter on it. You do need a directional antenna like a Yagi or a Moxon or something like that. On the website, I put some links to some very easy to construct antennas, and it's not like this is easy, and then here's like 27 pages of directions. I mean, it's literally like buy a tape measure from Harbor Freight, cut the pieces this long, strap it to a piece of PVC, and solder a piece of cable on the end. They truly are easy to do. I built a Moxon I'm going to play with. I don't know how well it'll work. It's supposedly pretty good. I used a piece of aluminum tube or copper tubing I had left over from a air conditioner install, and 3 dowel rods and some zip ties and a piece of coax cable I already had. Took me half an hour to build. So you can build one of these very quickly and easily. They don't have to be pretty. They don't have to withstand the elements because you're just going to hold them. So it's an easy way to get involved, especially if you're a technician class license.
And they're just for receive. So.
Right, and it's just for receiving. You don't actually have to transmit anything. So if you have someone who's not licensed that wants to do it or partner up with you, they're not at a disadvantage because all you're doing is receiving. The way it works is when we get there, I'm actually going to write down everybody's. You get an envelope. Inside the envelope, a sealed envelope. Inside the sealed envelope is the location of the fox. In case you can't find it after a period of time, you just want to give up and rage. If you open the envelope, you're disqualified. And then otherwise, on the envelope will be written the time you start and the mileage of your vehicle, because it's not a timed race. It is a who travels the least distance to direction find the fox. So you don't have to be fast. You can take your time and plan out your route. Like you don't have to jump in your car and it's not first one wins. It's who drives the least amount of distance, because if you have a big setup and you spend the time circling the whole area with a big radio direction finding setup, well, the person who has an HT and planned a little ahead and picked a couple high spots and found it right away is going to win. So.
And it's like Doug Hunter's patrol car will be set up to catch those that are speeding.
Yeah, right. we do want you to RSVP. That's for food purposes. The club is buying some subs from some sub place in Akron that Bob's very excited about. I can't remember what it is. I think it's begins with a T.
Bob knows food.
Bob knows food. So if Bob likes it, it's going to be good. So we do need to have, I mean, and if you don't RSVP, show up anyway, but do us a solid and actually RSVP. There's probably 16 people participating, I think. I think there's like 9 or 10 teams. There's a couple people that signed up. So you can do this in a team. You know, if 2 people want to get together, you can do it as a team. It's a great way to do some amateur radio stuff.
And this is in 2 days, Saturday.
Yeah, please RSVP by Saturday.
Right.
The event is on October 29th.
Oh, 29th, that's
Yeah.
right, it's the 29th, I forgot it.
Yeah, October 29th.
Yeah, you're right.
So. Any questions about the Fox? He knows what's up.
No good picture there.
That's it. Any other new business from the floor?
You shut off the,
Oh.
there you go.
Any other new business from the floor?
Floor doesn't have any business there.
What?
Floor doesn't have any
The
business.
floor has no business. Thank you. Floor.
Awesome.
Next meeting, Thursday, November 17th, same bat time, same bat channel. Just as a reminder, there is no December meeting.
Right.
So sign up for the Christmas party. Eric Moran, WDA KNL, is doing something interesting. Telecommunication simulcast, what it is, how it works, and why your scanner doesn't do it. So I'll be kind of curious to hear that because I'm not actually sure what all he's going to cover. He told me and I forgot. So, but Eric always does great talks. If you go back in the video archives, he did a talk last fall on time synchronization. If you like time and are a time nerd, go listen to his presentation on all the different time standards that exist in the world. So,
Mark Stutter had a question about the Fox Hunt really quick. All of Northeast Ohio, or is there going to be a boxed area, basically?
well, it's not going to be all of Northeast Ohio. It's going to be what you can hear with an HT from the Bueller's parking lot.
Well, that was his question. So
Yeah. I have no knowledge because I am actually playing. I would expect it to be in the southeastern Medina, northeastern Wayne, southwestern Summit County, sort of tri-county area.
Roughly the club area.
Yeah,
Yeah.
it's going to be the core club area. You're not going to be like direction finding to Youngstown. So the Fox transmitter, I'm pretty sure, is a 5-watt radio. It's not like we're putting with an antenna, right? It's not like we're putting a commercial 16-bay UHF in a tree on 100 watts. And hey, anyone hear the Fox? Yeah, it's in Canada.
Nice. Yeah.
Bring your passport.
Yeah, bring your passport, a sleeping bag, and no, it's going to be local. It's going to be in the Wadsworth, Norton, Medina, Rickman, Doylestown. Like, I mean,
Right.
It could be further afield than that. It's going to be in that area. They're not going to be driving all over Northeast Ohio. So
He could have it in Copley in his house, right?
he could.
He could be.
Well, Bob lives in. Well, yeah, Dave can have it there. Bob lives over on the far side of Rickman,
Right. Far side of Rickman.
so by the cemetery. So,
Yeah. We help take his antennas down.
huh?
We help take his antennas
His
down.
antennas are back up.
I know, but we
Yeah.
helped take the
We
original
took them
ones down.
down
Yeah.
and we put new ones up.
You put a mask up?
So
Yeah, I gave him a mask. About
I
30, 40 footer.
don't remember. Well, I was not there for the putting up of the new stuff. I
Dave
helped
was.
tear down the
Dave
old
was.
stuff.
Yeah. I helped tear down the old stuff. Yeah.
So. Anything else? 50-50?
737-238.
238.
Everybody okay?
Mm-hmm.
Oh, Nick. All right. He's
Yeah.
okay. He won money.
Diet Coke? Iced tea?
All right, Nick.
Yay, Nick.
Yeah, they are. No, these are my tickets.
What's the take, Russ?
I think it's $45.
45.
45. Nice. Paid for dinner.
Thanks. There, that's for the next repeater.
No, no, you keep it yourself.
Yeah, you have to keep it. You're not allowed to give it back.
Well, wait, Gary's not here though. Gary's the one who makes you keep it.
No, you gotta keep it.
Is Gary online?
Yes, he is.
Oh,
That's Gary's rule, and then, this is for doing the barometer.
There you go. You got paid. Only one to get paid for barometer.
Is he saying that?
Why you live in your shop?
So, no, what? No. Any other business? If not, I'll take a motion to adjourn. The business
Motion to
meeting.
adjourn.
Stefan, second, Russ. All those in favor?
Aye.
Anybody want to meet longer?
No.
All right. All right. We're gonna roll right into the next, the technical topic here. Since we didn't have any other volunteers to speak, you're all gonna listen to me talk again.
Nice.
So I'm going to cover an interesting project that's going to be talking about HF communications and critical infrastructure. So I have several disclaimers. First off, anything I say is in no way an official position statement or opinion from my employer, if you happen to know who that is. I am also not an electrical engineer, and anything I could say could be wildly inaccurate. And power grids are unimaginably complicated, and this talk simplifies and skips over lots and lots and lots and lots of detail. Like lots and lots and lots and lots and lots and lots and lots of detail. All right? With that.
This is the excavator.
What does almost everything need?
Power.
Electricity. I do work for a utility company. We have discovered that people like their power.
Yeah.
We've discovered this, right? Everything needs power. And specifically, for the purpose of tonight's discussion, communications requires power, except for the blender, which just makes the drinks when your communication is out. But in all seriousness, power and communications they go together, right? Your communications equipment, unless you're doing like carrier pigeons or smoke signals or
Tin cup and a string.
tin cup and a string, but you're not going to get very far with tin cup and a string, right? All of that requires electricity, right? So if you are working on repairing electricity, how do you communicate repairing electricity when you may not have electricity, right? So a couple slides of orientation. So this is an extremely simplified diagram that I think I stole from Wikipedia, if I remember correctly.
Nice.
So there's a couple key concepts that we have to talk about here. The first one is there are generation plants, right? This is what you call a power plant. These are small to large to very large facilities that generate power. It's in the name, right? So these power stations generate power at a relatively low voltage. Now, I want to be clear, when I say relatively low voltage, I'm talking like less than 230 kilovolts. So I'm not talking about 5 volts, right? This is lots and lots of power, but for the electric utility, it's lower, right? That gets stepped up into what we call transmission. So transmission is how electricity is moved long distances. And long distances is a relative term, right? You can have a transmission line that moves electricity between counties, between parts of a large county, or you can have a transmission line that brings electricity from a state away at a power plant, right? So that's all at high voltage in transmission. And that's what we're going to talk about mostly tonight. Then it gets stepped back down to what's called distribution, where this is where you have your house. Your house is a distribution customer. Almost every business on the planet is a distribution level customer. Even large steel plants, they fall into this category. But most of the world, or at least most of the United States, is in this box on the right-hand side, right? So there's a couple important principles about this that ties into communications, which we'll see in a minute. So generation isn't magical, right? So however much power gets generated has to be consumed. Like that's a inviolable rule of the power grid, right? So your input has to match your output. You can't generate a whole bunch of power and have it go nowhere. That doesn't work out very well. And you also, of course, can't want more power than is being generated because that leads to brownouts. Each power line has its own voltage and megawatt rating. So each power line can carry such and such amount of power, such and such a voltage with so much megawatts. And there's tons and tons of protection equipment that will cause the lines to go out of service if any of a whole bunch of variables are out of whack. Everything from voltage to megawatts to timing on the line, all kind of stuff, right? If the reactance of the line, volt bar stuff is out of whack, it'll cut the line off. The other important thing is that all AC lines that are interconnected, so we're talking about alternating current power, have to be synchronized within a very small window of air to its timing signal. So in the United States, you're probably familiar with the fact that this is 60 hertz. Right. So if you put an oscilloscope on your house power, you see a very nice 60 hertz wave, hopefully, coming down your power line. All of the AC stuff that you have in your house depends on that being 60 hertz within a very small margin of air. Why is this important other than that, right? Well, if you are trying to restore service, or you're building new service, or you're fixing service, you have to match what you're bringing back online to the timing that everything else is already using, which requires lots and lots of communications, right? And again, protection equipment trips these things off if they don't match. Like again, if the grid starts to get out of balance, there's whole groups in huge control centers that do nothing but, okay, if this is out of balance, we got to fix this. I mean, it's extremely complex. So there's two big buckets, right? The first is distribution. As I said, this is your house, businesses, most commercial and industrial locations. This is what's called distribution. When you have a power outage, almost always it's because a tree fell on the line, or a squirrel fried itself on the transformer, or I don't know. We have cases and cases and case records of all kinds of bizarre things that takes out power, right? I work in cybersecurity. We always joke that the biggest risk of the power grid is a squirrel.
Right.
Distribution issues are usually very localized, right? So, you know, you could have an issue at a line that maybe serves as part of a township or the downtown area of a small city. If you're in a bigger city, you know, a distribution might be a block or two, right? It depends on a whole bunch of factors. So outside of something like a massive storm, hurricane, you know, a big ice storm, things like that, distribution restoration is fairly localized. And yes, you may not have power right here, but you know, you drive 2 miles down the road and there's still power. Like you've probably seen this if you live in a larger neighborhood, you've seen where you've had a power outage and one street has power and the next street doesn't, right? A fuse blew, or you know, something like that. So outside of huge disaster, the impact of this is limited. Now, if you have huge disasters, you're usually talking about a combination of both transmission and distribution. Transmission outages are a huge deal. First off, transmission lines are very resilient, right? Secondly, transmission is how, as I said, all the power is distributed regionally. And if you start to have multiple failures, this can have some very, very serious consequences downstream of all the transmission lines. The most oft-cited case is the 2003 Northeast blackout. There's a really interesting video that came out a couple years ago now. It's on a channel called Practical Engineering, where the guy goes through almost second by second how quickly the transmission grid went offline in 2003. Tons and tons of reliability protections have been built since 2003. More recently, there was if you remember in June, there was a bunch of tornadoes in the Columbus area. Down there, they had a big mess because they had a bunch of transmission lines go out of service, which hampers restoration to, you know, the regular clients. Does that make sense? Everybody track that? Okay. So if you have a big transmission outage, load has to get shifted around. You have to bypass problems because you're trying to deliver power to where it has to go. So as I mentioned, all the lines have ratings on them. If the load exceeds the capacity of the lines, you have to drop load, right? Because again, generation has to match consumption. So you can have forced outage, you can have automatic protection systems. We have to balance it. But what happens is if you drop load and you drop enough load, you start dropping generation. And once you drop generation too far, you have to drop more. So you can kind of see what happens, right? If you have enough load shed, you have to turn off power plants because a power plant can only generate so much power within a given span, right? This is where you get into some interesting problems because you can't just like walk up to the button and turn the power plant on, right? It's not like, oh, go reset the power plant.
Yeah, but Homer's different.
It doesn't play the Windows start sound whenever you restart the power plant, right? Big power plants require small power plants to start, or very, very large diesel generators, one of the two. So why is this important to communications, right? So this is not a lecture about energy grid, right? This is about communications. Why is this important? Well, here's what has to happen if you're working on a major part of the electric grid, which is oftentimes called black sky, right? So you have to partition the grid into small parts. Then you have to take one little piece of the grid, turn it on somehow, right? And then you have to build paths from the little plant to a bigger plant. The bigger plant comes on and synchronizes itself, and you can turn on some other. So you start having to put all these things together, right? And then you have to start hitting things like public safety, hospitals, all those kind of things, right? While you're doing this, you have to make sure you're maintaining all the synchronization. You have to make sure that you're re-energizing the grid in sequence with the load available. And oh, by the way, fix all the broken things you find in the way while you're doing all of this, right? So, oh, that whole line fell down. Yeah, I'll turn it back on. Right? You have to fix all these things while you're doing all of this. So electric utilities are reasonably well prepared for all sorts of scenarios. As I mentioned before, this is a really, really complicated machine. It's one of the most complicated machines on the planet. So power outages, while you may not have them, is very annoying to you. But restoring power is actually very, very, very well practiced in the industry on how to restore the power. And we talk about this all the time. We drill on this all the time. So as I mentioned, we spend a lot of time talking about communications because as a utility, we have to be able to talk to ourselves and we have to be able to talk to other people. So what does that look like? Well, in 2022, it's an all of the above situation, right? We have mobile telephones, we have cell phones just like everybody else does. Landline telephones. We have tons of hardwired telephones that plug into a wall. Now, we're not riding that over a copper pair of wires like you think of from 25, 30 years ago, but we have, everybody still has hardwired phones on their desks, right? That goes over our utility-owned fiber optics network. We have land mobile radios. These are usually on the state systems now, so Ohio Marks. I forget that Pennsylvania just rolled out a new one, and I forget what the name of it is. We usually buy into the state systems. We have satellite phones, and we have HF radio systems. So Bill went, right? So isn't this a ham thing / what century is this, right? But it's a common but incorrect belief that no one but hams is doing HF radio. If you say to someone who's not currently engaged in amateur radio, ham radio, they're thinking about this, right, or this, right? That's the common picture that people have when you talk about HF radio or ham radio or radio like ham, right? You've got this big mental picture of the 1960s with these huge radios with all the dials and the gauges going up and down. But HF radios have been a mainstay in government radio and closely related entities with government for over 100 years, right? If you actually go back and read the history of radio, after World War I, for example, the Navy tried to take over all radio spectrum in the United States because it wanted to be in control of all radio frequencies for military purposes. So HF radio has been and continues to be in service with the government for over a century. And the marketplace reflects that, as you'll see in a minute. There's ham radios, and then there's government and commercial radios, right? Many first responder, federal, state, regional agencies and organizations are also very heavily invested in HF radio. I have a directory of all the ones who are licensed through the program we're going to talk about. I think if you print it out, it's 700 pages long of radio stations. But why HF radio specifically? Well, as hams, you know, that HF radio operates beyond line of sight without something in the middle. You can take an HF radio over here, you can put an HF radio over there. You don't need phones, you don't need internet, you don't need towers, you don't need repeaters, you don't need anything else in the middle, right? Obviously, trade-off. HF is very slow if you want to send data. HF also is impacted by the atmosphere. It's not as universal as a line of sight radio. So it's a tool in the toolbox. But we do have a wide range of frequencies to cover all of the daytime and atmospheric conditions that you run into, right? HF bands are broad because the transmissions are narrow, right? So when you see about all the cellular auctions and millimeter wave cell systems and people fighting over 6 gigahertz radios, like you're way up in that end of the spectrum because your transmissions are broad spectrum, lots of things. Your HF radio, even in this setting, you're looking about a 2.7 kilohertz wide frequency. You can pack lots of those into an HF bandwidth. That's also important because federal licenses don't have the same restrictions on symbol rate that amateur radio operators do. So if you're in HF, you're limited to 300 symbols, 300 baud per second in HF. The ARRL has been trying to get this rule nixed for like a decade because there's no point to it because it was put in place decades ago to not compete with commercial interests as well. No one wants, no one's fighting over 300 baud versus 2,400 baud these days, right? And there are a number of manufacturers that make hardened equipment that are suitable for what we'll call key and go usage. These are not radios that you're familiar with, that you're going to sit down, there's a big knob on the front, you spin the dial and you find someone talking and you wait your turn. You'll see what I'm talking about. I have a picture here. This is an actual crisis staging center. You can see utility trailers, truck, people back in the corners of staging tent. This is what a recovery operation looks like. Right? This is practices. This is how it actually works. One of the things that's used in this space is what's called shares. Share stands for the Shared High Frequency, I'm trying to remember what A stands for, Radio Emergency Service. This is a DHS program that comes out of the Cybersecurity and Infrastructure Security Agency that's part of DHS. It's called CISA. So what CISA has is, CISA has a program that has over 200 distinct HF channels for all shares users to use. Now, to be clear, just like everything else outside of amateur radio, everything is channelized. You have a channel, and you have a set of channels. You don't just, flip through the dial and find a space. Everything is channelized. These frequencies are spread between 2 and 18 megahertz. Interestingly, it also includes fun things like 200 hertz for LF alerting. I would love to say I could play around with that, but I don't have a small nuclear reactor and 60 miles of wire attached to my house. Also distinctly different than amateur radio is licenses are issued to a station, not a person. So just like a commercial radio system, there is a license that is given to a radio in a particular location for a particular use. It doesn't matter who, well, it matters, but it doesn't matter from a licensing perspective who uses it. It's the station that's licensed, not the person. So the station doesn't change. Like if you come to my house and you sit down and use my radio and you're licensed, you're not going to be NADI, you're going to be whoever you are, right? Well, in this case, the station is the station, doesn't matter who's using it. You'll see why that matters in a minute. In the shares program, there are almost 3,300 radio stations. There's probably more than that now. I think this stat was a couple months old. It represents over 590 federal, state, and industry organizations that are a member of this program. And that doesn't include all of the military use. So this is just federal, civilian, state, industry, and then the liaison between military and not. It covers all 50 states, the District of Columbia, Puerto Rico, and other locations. Membership is limited to federal, state, and local agencies of U.S. military for cross-industry discussions, as well as critical infrastructure providers and the NGOs that support them. You as an individual can't just go and say, hey, I want to do shares and sign up for shares, right? If you know George Rydell in 1EZZ, he's talked before about how he's a DHS communicator. He's been in Puerto Rico. George works for DHS and has a shares license, for example. This follows the FEMA regional model. So we in Ohio are in FEMA Region 5. It does not follow the call sign areas, but they have numbers. So in Ohio, your call sign number is 8. In NTIA land, you are number 5. And it's very regularly exercised. There's many formal exercising and training of this that goes on a weekly basis. There's a once weekly traffic net in the morning or late morning. There's an every night regional response net for FEMA at night. Lots of stuff going on. Any questions? Feel free to ask questions. So example stations. These kind of look like ham calls, but aren't really. George, as I mentioned, is NN India 5 Charlie Hotel. I have one in Alpha 5 JAM, which was kind of fun. I actually got my initials, unlike my ham call, which isn't my initial. But other agency stations. The Ohio EOC is NNA 5EM. Cuyahoga County is NCS 919. First Energy is NCS 251. The AT&T Regional Emergency Operations Center is WNR East 962. I don't know where that one came from. This is a map of all of the radio sites that participate here. Oh, here. So this one says 3821 as of July 1st. So all of those little yellow dots is where there is a known HF radio system that participates just in this program. That doesn't include other license types for other agencies for other purposes. This is just for shares.
It's interesting the distribution, especially around Tennessee and Western Carolina. So
there's a fascinating amount of government stuff in Tennessee.
Yeah, there is.
Like, look up why TBA was really built.
Yeah, exactly. Yeah.
Right?
Lake Norris.
Yeah. And they have a whole bunch of these maps. There's a map for ALE coverage, which we'll talk about in a minute. There's a map for WinLink coverage. This heavily uses WinLink, but interestingly on high speed for HF modems. It's a very robust, very interesting program. There's a monthly working group meeting that happens where they come in and talk about different issues and they have technical presentations. It's very much like an amateur radio meeting, except with 500 people from industry.
Do they have food?
It's virtual, so you can bring your own food. So here's some example equipment that you would find in one of these. This is stuff we've worked on. This is a Codan Envoy X2220 radio. This is an HF radio. It is a full SDR. The specs say 100 watts, but I know for a fact it's 125 watts. I'm not sure why it says 100 watts in the specs. It has digital voice in a mode called TWELP. which is just a fun word to say, 12. It has something called ALE, which we'll talk about in a minute. It has link encryption, and you can have multiple control points, which we'll talk about in a minute why that's important as well. Actually, we'll talk about that now. First, so ALE. ALE is available in ham radio, but it's not often very used. It's very heavily used in this system.
Mars too.
And in Mars, yeah. So what happens is your radio does what's called soundings, and it's very much if you think of sonar. Every so often, your radio will go through a pre-programmed set of channels and say, hello, I am in an Alpha 5 Juliet Mike, and then it'll move to the next channel. Hey, I'm in an Alpha 5 Juliet Mike, and move to the next channel. Say the same thing over and over and over. And then it will listen for 10 minutes. And it will build a dictionary of all of the data transmissions that it hears by station and builds this up into a call book. So I can go onto this little handset, open up what looks exactly like a phone book on your cell phone, key down to whoever I want to talk to, press a green call button, and it will then it'll this table, and it'll say, okay, have I heard this station before? If it does, it starts going, okay, station, are you there? Nope, move to the next station, are you there? When you get connected, it takes about 30, 45 seconds. When you get connected, it literally rings like a telephone. And the other end hits the button, hello, and you're connected. And that's one of the advantages of having channelization, is you can step through a set of defined channels and make ALE calls. So we talked about my multiple simultaneous control points. So this Codan Envoy radio can be controlled simultaneously by all of these things. So on the top left is the actual handset that can be connected directly into the radio. Going clockwise, it looks like a handset, but it's actually a software program that you can run on any Windows system. It uses IP connections to talk to the base unit. Going around the circle, that's an app on a phone. It's not as fun looking as the actual software app, but you can put it on your phone and it'll talk to the radio over IP, cellular, whatever connectivity you have. And then you actually have this pretty awesome looking dispatch console, right? All of these are called control points, and they all work all at the same time talking to multiple radios. Each one of these control points can be programmed to talk to one or more RF units. They can only talk to one at a time, but they can talk to multiple of them, and then you can pick it out of the menu just like anything else. And it's multiple media for connection. You can have it directly wired. You can have it connected over IP networks. You can have it connected over cellular networks. And you can have hardware and software clients. So why is this important, right? So remember what I said before about how, for example, in the electric industry, we have our own fiber optic networks. We have our own internet connections. We have our own wireless access points. We can start to strategically locate radios all over the place. And we have some very resilient networking where we can pretty much be assured that we can talk to all the radios from multiple control points. So we can divorce the concept of where the radio with the antenna is from where the person who's operating the radio is, to basically create a mesh of ability to communicate over this particular system. Does that make sense? But you can also build these into field kits. So this is an example of a field kit that we have. It has the RF unit, and you can see here the little handheld is wired into it. But this little box right here is really interesting, right? That is a communications hub. And what it does is it connects the RF unit not only to its handheld, it also has wired Ethernet and Wi-Fi. It is a full Wi-Fi router that you can connect a laptop or a computer to and use it to communicate with your laptop to send digital messages over the system. You can also plug it into a field deployment network or wirelessly connect it to a field deployment network and extend its capabilities to where you've set up this radio. So if you imagine you're in a disaster recovery staging area, your comm unit rolls up, the field technician who's providing the network, because we actually build networking, right, at our response site, you walk up and go, here's your connection. You plug it into one of the ports on this unit and it joins the network that it's part of. These field kits have an internal lithium battery that'll work for, I think it's 6 hours. I haven't tested it to see if it actually lasts for 6 hours. It also has an external battery pack that's a lithium iron phosphate battery that'll last for 24 hours of use. It comes with a complete NVIS field antenna system, and it also comes with a PACTOR 4 data modem. If you're not familiar with PACTOR 4, it can transmit data over HF at about 2,500 baud up to 3K for really good conditions. For HF radio, that is really, really fast. It's not fast internet standards, but for HF radio, where you're passing small data messages, very fast. So, why do we want to do any of this, right? Well, like I mentioned, we can have multiple RF units at multiple locations with multiple clients at other locations talking over those radios depending on what you need. So this is a light blue fiber optic network, for example. Obviously, we have the ubiquitous power with that are radiating in patterns that don't really exist in reality. But all these little blue arrows are HF radio communications. So, for example, we can talk to FEMA if we need to. We could talk from a control center to a staging area, right? So outside of a disaster area, talking long distance into a disaster area. And then you can have mode handoffs, right? So you can have a comms controller sitting there with an HF radio on one side and the field portable system that they're using in that state for repair operations and pass messages back and forth from the people in the field back to the control centers. This would obviously be a last resort communication. We would choose other technology in advance of this, but if this is what you have, this is how you can communicate. Does this make sense? Mm-hmm. So what do we have to communicate about and who do we have to talk about, right? Well, we do a lot of talking and a lot of message passing in the utility. Grid operations, we have to do damage assessments, right? In a major storm, Ken and the Aries people talk about damage assessments. We have whole teams that go out and do nothing but, okay, there's a tree on a line here. We need a 4-man vegetation crew to pull it off. And then we have a 6-man crew. We need to set a pole, and then we need a lineman to come out and splice the line back together, right? We have people that go out and do nothing but that. Switching orders. Switching orders are changing the state of the grid. Switching orders are incredibly essential to have communicated correctly, safely, and reliably. You have repair orders. As I mentioned, if this is a disaster, you're turning the grid back on while you're repairing all the stuff that you're finding, right? Planning and protections. Planning and protection is a huge important function in the utility. Planning and protection basically models the state of the grid and says, okay, if this happens, what do we do? If this happens, what do we do? Oh no, this happened, what do we do? This is a continuous function. And response logistics, right? If we have to respond to a major disaster, we're not just sending about a handful of trucks. We have huge response capabilities, everything from tents to craft services. We have people who do nothing but hotel and rooming logistics, where to find equipment. We have suppliers on how to get us equipment that we need. All kind of stuff has to be communicated in response. And what about external? Well, we don't do this in a vacuum, right? We have peer utilities, we have customer utilities. We have to talk to what are called regional balancing authorities. We have to see to cross-region power transfers. There's actually a really cool website. If you look up, it's called PJM. It actually has a map of all the power that flows in and out of our region at a given time. It's publicly accessible. It's kind of fun just to see how much power is moving in and out of Ohio, for example. We have to have generation dispatch, right? Utilities aren't vertically integrated anymore. We don't own our own generation plants for the most part. We have to call plants to get status on things. Public safety, right? We want to know when lines are down. We have to know when lines are down. We want to be able to communicate to emergency response. Like, oh, no, don't go there yet. Hold on, we haven't been able to turn that off. Government agencies, right? In a big disaster, every government agency is going to be out there doing stuff. They're all going to want to talk to you. and customers, right? We can relay data about outage restoration to customers in the media to tell people what's going on. We don't just make up numbers and guess. It's kind of funny. You get your power will be restored by 8:47 p.m. Well, there's actually an algorithm that decides that, right? It goes up and down. It's not just someone going, that looks like 8:45. Right? It can feel that way, but I assure you that's not actually how it works. So there's lots and lots of communication that has to happen for service. So here's a theoretical example. So on the left, we have a control center. In the middle, we'll have a staging tent. And I couldn't find a good picture other than it looks like a circus tent. So take the tent slightly more seriously than the icon means. And then we have a line worker with a mobile radio. And then so on this side, we have our HF system. On this side, we have like our state radio system. Now, I feel compelled again to mention, this is not how this actually works. This is extremely simplified storytelling that does not represent real, safe, complete communications about grid. So if anyone ever finds this presentation, please know this is not how it actually works. I'm just telling you a story. So if the control center, for example, says, hey, we have a 345 kV line out between this tower and this tower. We need someone to go take a look at it. So let's assume there's no other communications available. The control center can talk to the field recovery unit. They'll turn around, they'll pick up their state radio and say, hey, I need this crew to go to location XY. We also have a huge investment in GIS mapping data, by the way. I need someone to go to this particular location, assess the damage, call out a repair crew, do all the things we need to do to put this piece of line back in operation. So that gets communicated to the crew gets dispatched. Again, whole process about how this works. Coordination will call back and say, we've dispatched the crew, the ETA is such and such, take that into account. So some time will pass, the line gets repaired, field crew would radio that back to the staging area, the staging guy would turn around, pick up the HF radio, call the transmission center, say, line alpha beta 345 between these two powers has been repaired, take that into account. Sometime later, the control center might say, okay, we're going to re-energize this particular line between this, when we re-energize this, when we re-energize this line, it should fix MN and P, right? Again, super simplified of how all this stuff actually works, right? But that's the kind of example of how you would use this to get to a point where you don't have to use radio systems to communicate. We can go back to our normal business processes of cell phones, internet, data communications. I don't have any more slides. As I mentioned, the transmission of this data, it has to be super accurate for safety and reliability reasons. A lot of this communication would probably actually happen over data. So remember those PAC-4 modems I was talking about? We would actually be sending pre-formatted, if you ever used WinLink or FLDigi, there's a form, you fill out the form, but then in the background it like compresses all the data, transmits it, and FLDigi breaks it back out into the form. So you can take a switching order, for example, fill out the switching order, and it uses WinLink, just like hams do, smushes it all up into a small package, sends it across, and on the other side, out comes the switching order. And then you can verify that, right? There's lots of communications protocols built in to verify that the operation you're doing is going to be done safely. So data is a huge component of this. So, yeah.
How is it encrypted, or is it not encrypted, or?
It can be. All of the radios we have a key management service that will set encryption keys on all the radios, and it's just a little button. You can click the button and the communication's encrypted or not. Right now, you can only really do that between your own radios. Right? You're not trying to do key exchanges with other people, or you can hit the button not encrypted. That's pretty much it. Cool. Any questions, thoughts?
That's it.
Any issues?
Yeah, the Codan radio you talked about, that have an automatic antenna tuner in it that goes to the antenna?
Nope. You have to have a broadbanded antenna. So usually in these type of applications, you have like a terminated voltage dipole. Because you want them to be broadbanded across a wide range. You can buy antenna tuners, but then the problem you start to run into, for example, is if you want to do ALE, then you have to retune every time you try to change frequencies. And then it makes the transmission sounds take too long.
Because you've got non-technical people necessarily using it.
Well, you have to do it automatic, because this is all automatic. Like, you can't go in and fiddle with the settings as a user on the hand. Like, this has a huge programming interface. We go in and we program the radio to behave exactly like we want. There's no menu to go in, oh, I know, I don't like this, I'm gonna go check. You can't do that for these radios.
How much more do those radios cost?
About $13,000 each in American dollars. That just for the black box model.
Yeah. Nice.
But again, these radios are essentially bulletproof.
Nice.
When we were meeting with one of the technical guys, we had forgotten a dummy load. And we're like, yeah, well, we wanted to try some stuff. We got dummy. I said, don't worry about it. But just hook up a bare piece of coax. That's enough load. Okay. Worked. We didn't blow it up. So.
Was this the system that you were testing, that pop-up tower that you and John were so happy about? Okay.
Oh yeah, yeah. So the end of it is antenna. So if you haven't seen this video, look up on YouTube something called a roller tube. So a roller tube is a fiber optic tube, or carbon fiber tube that actually has two states. You can roll it up into a roll. It's about that big around, or you can roll it out across the ground and it will automatically expand out to a 20-foot antenna, a 20-foot
tower
mast.
That is cool. Yeah.
Also very expensive. Because I looked at one to buy one for the club, and I'm like, oh yeah, never mind. We're not going to do that.
Better to have a repeater.
It costs more than the repeater. Let's just put it that way.
Nice.
But again, it's a true. It's not like military surplus. You know, the local, survivalist store. It's literally true mil spec. Like probably stops a bullet. And we joke that the stakes that it comes with are like personal defense weapons. Like if someone charges the communications, like you can pull up the stake, and I mean they're like these huge, like sharpened point stakes. We pull them out like, holy cow! Yeah, you literally can
just let your enemy run it.
They are shiny steel. They're probably not silver, but
yeah, silver. Well, cool.
That's it.
Thank you.
Thanks, Jason.
We're done.
That's it.
Adios.
Have a good evening.
Right, so we roads are very careful.
Yep. All right.
Well, Dave.
I will see you in contest.
Hey, thank you.
Hi, Gary.
No, I don't have. I've worked on the work for a couple of years.
I may.